to school, yeah.
The bus was supposed to come like 30 minutes ago.
Yeah, so can we go out and wait? Oh, he's already here. Let's go.
My bus is here!
Okay, let's go. We're already late.
Okay, hurry up. We're already leaving because of the bus.
Okay, let's go in. Okay, let's go to the chemistry class. Our first lesson is chemistry. Teacher said today we're going to learn about isotopes. What's that? Oh goodness. Okay, let's go to our class.
So yeah, my chemistry teacher said your science teacher, your chemistry teacher is sick.
Okay.
So you have to be in the same class as me. If you want to know about it, you can just sit down and listen too. Let's go.
Okay.
Hey, come on, we are late for class.
Oh yeah, today we're going to learn about
Isotope.
and teacher said our first.
No, we don't have the same teacher, and how are you supposed to know about? How do you know that?
I don't know.
Did you look at my schedule again?
Oh no, I did. Okay, let's watch the video. Teacher said she's going to put for us.
Okay,
sit
on
down.
the board.
Okay, the board is going to change into a video.
Let's look at the board.
Okay, look at the board.
You understand this video. The identity and chemical properties of any atom are determined by the numbers of protons in its nucleus. As atoms get bigger and heavier, the nuclei get bigger and heavier, and the protons need a sort of nuclear glue to help hold them together. Neutrons provide this glue and prevent the positive charges of protons from repelling each other, thanks to something called the strong nuclear force. Elements can exist with slightly different numbers of neutrons, and we call these isotopes of an element. It is particularly common for heavier elements where a lot of neutrons are required to hold the nucleus together, but smaller and lighter examples include the isotopes of hydrogen. Hydrogen-1, hydrogen-2, also called deuterium, and hydrogen-3, also known as tritium, are the three isotopes of hydrogen. They have 0, 1, and 2 neutrons respectively. Tritium is the heaviest isotope of hydrogen as it has a larger mass number. Note that in each of these isotopes there is a single proton. This means that the element is unchanged, and that's the important point. It is still hydrogen and will react chemically in exactly the same way. There is often more than one stable isotope of an element. In fact, much of the world around us is made up of stable isotopes. However, sometimes there aren't enough neutrons in a nucleus, or there may be too many for it to be stable. An analogy is a person carrying boxes. If you try to carry too many boxes, you'll end up dropping some. And if you continue, you'll keep dropping boxes until you reach a manageable amount. This is your stable state. And nuclei behave in a similar way, and they will try to stabilize themselves. If there are too many protons or too many neutrons, the nucleus can spontaneously rearrange itself and throw out particles in the process. This is essentially what happens in radioactive decay. Isotopes that have unstable nuclei like this are known as radioactive isotopes or radioisotopes. In our hydrogen examples, tritium are unstable and are hence radioisotopes of hydrogen. The more unstable a nucleus, the faster it will try to rearrange itself into a more stable state. And another name for this process is radioactive decay. Radioisotopes are often used in medicine to trace aspects of body chemistry or blood flow. For example, a small amount of the radioisotope technetium-99 may be injected into the bloodstream to show up on medical imaging and X-rays, and this is known as a medical tracer. Tracers can be used by chemists to understand how a reaction works. Atoms of radioisotopes can act as markers, allowing chemists to follow how a reaction sequence occurs. And of course, radioisotopes are also used in radiotherapy to kill malignant cancer cells. So, as you can see, isotopes are important in modern science, and so we'll finish with a summary of the key points. Isotopes of the same element have the same chemical properties. Some isotopes are stable. Isotopes that are unstable are radioactive. Radioactive isotopes are...
But I saw one textbook on teacher's table 1. Let me just see on this page what is isotope. Oh, I found it.
Okay.
Isotope. Okay, can I just tell you what's isotope?
Yeah.
Okay, in the book, in our chemistry book, okay, isotopes are atoms that have the same proton number but different nucleon number. That means they are the same atom, but they have different number of neutron, but their proton number is the same. No wonder I see the same atom with different nucleon number. Oh, now I understand. Okay. Do you see our teacher around?
Yeah. I see her.
Oh, teacher.
Uh,
Teacher, I want to ask you, that day
Yes.
in the school, there was a pipe leakage, right, teacher?
yeah, that day last week when you were like in your class and your sister and me went and figured it out.
Alright, teacher, can you just explain? Because in our chemistry book, it's written one of the use of isotope is to find leakage in underground pipe. That means they use sodium 24. Is it true, teacher? It's written in the textbook here. One of the use of isotope is sodium 24.
Yes.
Oh, that means that day when they came to our school to find where was the leakage, they actually use sodium 24. Right. Now I understand, teacher. Okay. Okay. Okay, so what are we going to, what notes we're going to write now?
Okay. What is the uses of
Isotope. Okay. Okay, let me just show my notes now. Okay. Okay, you write down now, students. I'm telling you what to write. All right. Okay, number 1.
Number one.
Okay, it is you. Number 1.
Number one, Cobalt-60 to kill cancer cells without surgery.
Okay, wait, teacher. I'm still writing. Okay. Cobalt-60 to kill cancer cell without surgery. Okay, done, teacher. Then what else? Okay, number 2, teacher.
Phosphorus-32 study of plant metabolism.
Okay. Phosphorus 32 study of plant metabolism, teacher. Okay, got it. Okay, let me write first. Okay, is there any other users? Okay, number 3, teacher.
Carbon-14 engine of effects or fossil egg.
Okay, carbon 14 to estimate and writing of artifacts.
You're just staring at the book.
Yeah, but I'm reading, teacher, while writing. Sorry.
You
teacher.
can write at the side.
at the side.
Yeah, if you don't have like a workbook. If you don't have a book.
Yeah, sure, teacher. Okay, I think it's time for our gym now, right?
Gymnastics, yeah. Since there's no other teachers today, I have to take you to the gymnastics.
Right.
Okay. You can give me back my book, right?
Yeah.
Okay. Thank you.
Thank you, teacher.
You're welcome. Now let's go to the gym. Yay!
Yay!
That's like my favorite part. Me! Yay! Hey, are you coming?
Yep, wait for me.
Yes, wait for me yourself. Angel, slow down. Don't run. Okay, come on.
Okay, teacher, come, let's go.
Okay, so we are here. Come on, let's go. Okay. Okay, let's go. Let's go. We have to get ready in our uniform.
You mean our gym attire?
Yes, we have to get in bed. We have to get our clothes. Come on. Let's go. Okay, there's one gymnast here. This is one of our classmates from gym. She's a new one, so hey, come on. Yeah, come on. This is we are supposed to hurry up.
I lost.
You made it. Okay. Okay. You go on the rings. I will go on the beam. Okay. You go on the beam. You go on the rings.
Okay.
Okay, let's go upstairs. I'm still in my gymnastics clothes. I don't have time. Doesn't matter what clothes. Doctor.
Yeah, yes,
My sister thinks at gymnastics class. And she needs.
Oh, she need a checkup. Come for this one.
It's right here. Come on, let's go.
Okay, put her on top here. I think I need to check her and give her some radiotherapy. Whether she can walk, I need to check. Okay. Doctor, what's happened with my sister? What are you doing now? Oh, Cobalt-60 fault. No, I don't think so.
The same thing as my little sister has.
No, your sister is going through so much radiotherapy with Cobalt-60 for killing her cancer cell.
But is she going to be okay? Is she going to be good?
I don't know.
My parents also had that, and then they didn't survive.
Oh, really?
Yes, so
She's going through a lot of treatment. Iodine 131 also to treat her thyroid disorder. So I do not know what's going to happen.
She's the only family I have.
Oh, that's so sad.
Now I have to live by myself only if she don't survive. Who am I going to live with?